Hi everyone, my name is Nilo, and I'll be teaching you guys Introduction to Frequency Count. So without further ado, let's begin. So before we get into the technicalities and the concepts regarding uh, frequency count, we must first understand the motive behind it. So why do we analyze algorithms? So the number one reason is we investigate the behavior. So there is a concept regarding in CC 1, if I recall correctly, that there is an input, the process, and the output. So uh we now focus on the process. And the process we try to understand how long the process will take and how much resources the process is going to be getting. And that depends on the input that you're going to be providing. So if your input size is large, like it's a large amount of numbers or strings or characters, whatever you're trying to put in, whatever you're trying to input, logically speaking, it's going to also take a while for it to give its output. So by that logic, if you have a small number of input, it's going to be faster basically. So just do note that that's the reason why we want to investigate the behavior. So that if the code runs inefficiently, if you have this number of input, then we should uh we should at least know or be aware that it's not efficient enough. And number two is resources are limited, both time and space. So we know that, us humans or us people, if something takes a very long while to make it happen, we tend to get impatient. And at the same time, we know that uh in our computers rather, um there's always going to be a limited number of space for it to handle. So we can't always store unlimited information. So that involves pictures, videos, files, games, movies, or whatever you like to store. So that's the reason why we want to use as little space as possible while trying to make it as efficient and or as fast as possible. And what is our basis for the algorithm performance? So as mentioned in the second reason why we try to learn the analysis of algorithms, so there's the time complexity and then there's the space complexity. But in this case, we're going to be focusing on time complexity since we want to know how fast or the number of steps it will take in order for the program to run. And that really depends on the input size that you're going to be providing. So let's try to go through each example that I have prepared. So in here, I have two lines of code, and in each line there is a variable that takes in a value. Whenever that happens, where a val or wherein a variable is going to be taking a value, that counts as one step. So just do note that uh, whenever you're trying to get the frequency count, all you're what all you're trying to do is getting the number of steps. So in this case, since that there is one step in line number one, and then there is another one step in line number two, that means there is a total of two steps. Well, that's because it's just one step plus one step, and the total count is two or two steps. So that's basically the gist regarding the basics on the frequency count. Now we're gonna go a bit complex. So we're gonna go for the conditional statements. So in this case, you have an if statement here and then the else statement. And each inside of the if statement and the else statement has a number of statements here. So how do we evaluate this or how do we solve this? All right. So let's focus here first. Let's focus on lines number 2 and 3. So in this box here, or basically whatever the statements are in from the if statement, we have two statements. And then for each line, there's one step, since basically it's just getting the variable is going to be storing a value. So in this case, there are two steps here. And then for the else statement, there's only one statement. So let's focus on this. So since that there is only one step here, because there's only one variable that's going to be taking a value, that's only one step. Now, how do we solve for it? So this time, you're going to be comparing which one is greater. Is it this? Is it the statements that fall under the if statement, or is it the statements that fall under the else statement? So as you can see here, that we already solved for the value. We know that 2 is greater than 1, so we're gonna be getting the value, the frequency count from this statement here. Just do note that in case that there's a lot of steps that occurred in the else statement, then you go for the else. But since in this case that the if statement is already has a greater value of steps, we're gonna go for it for the if we're gonna go for the statements that fall under the if statement. And then you're going to be adding it by 1. So that is going to be a value of 3. Why plus 1? Because nonetheless, when you're going to be solving for the if statement, you're going to evaluate the condition here. And that already counts as one step. That's the reason why in the formula here, it's 1 plus the maximum value of the count of A and the count of B. Count A refers to the number of steps occurred inside of the if statement, and then count B is the number of steps that occurred in the else statement. Hence, I just put here the parentheses na A, and B, just to give a clearer example. So that's why if you do 2 and 1, the value of the max here is going to be 2. So 2 plus 1, that's 3. So in the case, the total count is 3. Now we're going to go for the for loops. So in this for loop here, the rule dictates that you're going to be solving it like this. You have your upper bound and then you have your lower bound. Your lower bound's value is the one that's is the value from I. And in order for you to solve this, it's upper bound minus lower bound plus 2. And then anything inside of the for loop is going to be plus 1. So if you notice, inside of the for loop here, in this case, it's going to be one less step. That's why it's plus 1 instead of plus 2. So let's try to put this into an example. So here, I have a simple for loop with 2 statements inside. And we're gonna have to solve the for loop here. So it's going to be n minus 1 because it's upper bound minus lower bound. So it's n minus 1 plus 2. So that makes it n plus 1. And then here, n minus 1, that's because the upper bound minus the lower bound plus 1. Same thing for here, n minus 1 plus 1. So to simplify, it's going to be n and n because minus 1 plus 1 is 0. So that just cancels it out. So we're going to solve for the total number of steps. So it's going to be n plus 1 plus n plus n. Then that makes it 3n plus 1. And that's the reason why the total count is 3n plus 1. Okay, now we're going to go for the while loops. So for in this while loop, the rule dictates that you have a upper bound and lower bound as well. So here you have a value of x here. So since x is equal to 0, that takes in one step. And then you have a while loop here. The condition is x is less than n. So here, the rule says that it's going to be n minus x plus 1. So it's going to be plus 1 for this while. And then anything inside of it is going to be one less step. That's why you don't see the plus 1 here, but rather just n minus x. There's nothing here. That's because 1 minus 1 is 0. That's why you don't have to put that's why there's nothing here. So it's just n minus x. So we're gonna have to solve for the total number of the total number of steps for the frequency count. So if you can see here, it's going to be 1 plus n minus x plus 1 plus n minus x. So we just basically add them up from here. And then we're going to be substituting the value of x, since we already know the value of x from the program here, or from the code here, rather. So it's going to be 1 plus n minus 0 plus 1 then plus n minus 0. So we just have to simplify the equation further. It's going to be 1 plus n plus 1 plus n. And then your answer is going to be 2n plus 2 because n plus n is 2n and then 1 plus 1 is 2. So the total count is 2n plus 2. However, if you have a less than or equal to sign, so if you just do note that if you have an equal to or if you're going to have an equal to sign, that's going to be plus 2 instead of plus 1. So if you notice the difference, this one is just plus 1 because it's just a less than. But if you have a less than or equal to, it's going to be plus 2. And then anything under it is going to be one step less. So that's the reason why we have plus 1. And then you just have to do the same thing like the one we did here in this while loop. So we just have to plug in the value of x and then simplify it. So it's going to be 1 plus n plus 2 plus n plus 1. So the answer is 2n plus 4. The reason behind this is n plus n, that's 2n. And then 1 plus 2 plus 1, that's 4. And the total count is 2n plus 4. Now let's go for the do while loops. So in here, unlike the while loops and the for loops, the value of the while loop or the conditional while loop here is the same thing that happens inside of it. Well, that's because you're already running the statements first before you do the condition check. Unlike in the while loop and for loop, you're checking first the condition and then you're gonna be running whatever. If it satisfies, you're gonna be running under it. But if it doesn't, you skip it. But in here, you do it first before you check. That's the reason why the value of the conditional while loop here is the same value of whatever happens inside of this loop. So in this case, it's going to be n minus x. Unlike in the while loop, it's going to be n minus x plus 1. In here, the rule says that it's going to be n minus x. And then inside of the loop is going to be n minus x as well. So you just have to solve for the equation. So you know that x is equal to 0. So it's going to be 1 plus n minus 0 plus n minus 0. And it's going to be 2n plus 1. Why? Because n plus n and then 1 minus 0 minus 0. So that's basically 1. All right. So and that's the reason why it's 2n plus 1. Okay. In here, we have a less than or equal to. So since there is an equal to sign, it's going to be plus 1. So same thing. So it's going to be n minus x plus 1. And anything inside of the loop is going to be n minus x plus 1. So you just have to put in the value of x, do the same thing like what we did in the do while loop, and then you're going to be getting 1 plus n plus 1 plus n plus 1. And it's going to be 2n plus 3. I'm sorry regarding this one. This is a typo, but it's supposed to be 2n plus 3. Why? Because n plus n is 2n, and then 1 plus 1 plus 1 is 3. And that's why it's 2n plus 3. And here, we have the nested loops basic. So I just want to point out before I explain regarding the nested loops that this is just an introduction to frequency count. So summations and other advanced topics are not covered in this lecture. However, just do note that there is a similar behavior regarding the advanced nested loops, but I suggest looking through your resources in order for you to effectively answer nested loops that involve summations. So in here, I have a nested loop. And the value of I and the value of j will run up to n times. So that's the reason why we have the reason why there is a nested for loop here is because the inside of this for loop, the I for loop has a loop inside of it. That's why it's called nested, is because you have a loop, and then inside of that loop, you have another loop. So just think of it as inception, like a dream within a dream. So you have a loop, and then you have another loop inside. So how do we solve for this? What I like to do is I like to solve for the innermost loop before the outermost loop. But in this case, since this is simple, I would like to solve for the inner loop, the innermost loop. So same thing, the for loop, it's going to be n minus 0 because the upper bound minus the lower bound plus 2. So it's going to be n plus 2. And then we're going to solve for the value of the outer loop. So similarly, this is going to be n plus 2 plus n minus 0 plus 2. And then anything inside of the loop is going to be n minus 0 plus 1. And that's the reason why it's n plus 1. So what do you do now? For this one, you're going to be multiplying this value here by this value because you're going to be running, while you're running n plus 2 times here, you're going to be running n plus 1 times here as well for the outer for loop. That's why you have to multiply it. So in order for you to do that, so it's going to be n plus 2, since this is the first line here. This is line number 1, this is line number 2. So for line number 1, you have n plus 2. And then for the second line, so you have n plus 2 multiplied by n plus 1. So we're going to be solving for, we're going to be simplifying this further. So it's going to be n plus 2 plus n squared plus 3n plus 2. So we're going to have to use the FOIL method. So that's n squared, and then n here, that's n. This one is 2n, and then this one is 2. So n squared plus 3n, because n plus 2n, and then plus 2. So that's the reason why this is the value here. And then simplify it further. So that's n squared plus 4n plus 4. Reason is you have n squared here plus 4n, n plus 3n, and then 2 plus 2 is 4. And that's why the total count here is n squared plus 4n plus 4. And that basically concludes the introduction to frequency count. I thank you for listening. If you do have any questions, please feel free to consult with LaSalle Computer Society or Peer Tutor Society regarding the matter. Thank you.